Welcome girls. In today's lecture, we are going to see definition of characteristic function, few theorem results and examples. To start with, let me explain you the characteristic function definition. So characteristic function is a real valued function. Okay, it is defined on a set A. The set A is a subset of the universal set S. Okay, so always my set A will be a subset of my universal set. Okay, so a real valued function is called a characteristic function. It is denoted by psi suffix A, and this will be equal to 1 if it belongs to this x belongs to A, and it will be equal to 0 when x doesn't belongs to A. So the pictorial representation is this. So if my A is here A is a subset of my S, and the psi will take the values from A, and it will be 1 if it belongs to A, and it will be 0 when it doesn't belongs to A. Okay, now I will see an example. Suppose if my A is a set with element 6, 7, then my psi A of 6, what will be the value of psi A of 6? It will be 1. And psi A of, let me take some 10. Psi A of 10 will be, will this 10 belongs to A? No. That means the value will be 0. I hope you understand the very basic definition of characteristic function. We'll move on to the theorem. The theorem statement is this. Let S be a universal set if A and B are two subsets of S. Here now we are taking two subsets in the universal set S. Then the union of A union B characteristic function with the union subset A union B is nothing but maximum of characteristic function of A characteristic function of B. Characteristic function of A intersection B is equal to minimum of characteristic function of A characteristic function of B. Characteristic function of A minus B is nothing but characteristic function of A minus characteristic function of B, provided my B is contained in A. So this minus A minus B is defined only when my B is contained in A. The next one is psi A dash, that is complement of A. The characteristic function on complement of A is equal to 1 minus psi A. And the next one is characteristic function of the universal set value is 1, characteristic function of the empty set value is 0. We'll see the proof one by one, and since it's a characteristic function, psi is a characteristic function, we have only two options, that is whether x belongs to A or x doesn't belongs to A. Just keep this in mind. For all the proofs, we have to check both belongingness as well as not belongingness. Okay, we'll see the first proof, first subdivision proof. The first subdivision is this: psi A union B is equal to maximum of psi A psi B. Just take an element x belongs to A union B. Now by the definition, have psi of A union B is what? 1. Now you just take this as equation 1. Since we have taken x belongs to A union B, you replace this union by R, which means x belongs to A or x belongs to B. Now again by the definition, my psi A will be 1, psi B value is also 1 since it belongs. Okay. Now the right hand side, you substitute in the right hand side, maximum of psi A comma psi B will be maximum of 1 comma 1, and the value will be what? 1. So now from first and second equation we have proved what characteristic function of union set is nothing but maximum of the characteristic functions. Next we have proved the case for belongingness. Next we will prove the case for not belongingness, that is x doesn't belongs to A union B. If it doesn't belongs to A union B, then by characteristic function definition, the value will be what? 0. Since x doesn't belongs to A union B, does not belongs to A, you replace union by R, it will be x does not belongs to B. So psi a of x is equal to 0 or psi b of x will be 0. So now again right hand side, take the right hand side, maximum of psi a of x comma psi b of x will be maximum of 0 comma 0 and the value will be what? 0. Now from third and fourth equation we got the result for union. Okay, next we'll prove for intersection. So it is similar to your union. We have to consider two cases, belongingness as well as not belongingness. So let x belongs to A intersection B. Then the characteristic function A intersection B on x will be what? 1 by the definition of my what? Characteristic function, since it belongs. Now you just take this as equation 1. Now since x belongs to A intersection B, you replace their intersection by what? And. So x belongs to A and x belongs to B. Again by characteristic function definition, it will be psi A will be of x will be 1 and psi B of x is also 1. Now substitute in the right hand side. Minimum of psi A psi B will be minimum of 1 comma 1 and value will be 1. Now first and second equation gives you the result. Now we have seen the result for belongingness. Now we check for not belongingness. So if x doesn't belong to A intersection B, then psi A intersection B value will be 0 by definition of characteristic function. Now that just take that as equation 3. So since x doesn't belong to A intersection B, you replace intersection by and. It will be x doesn't belong to A and x doesn't belong to B. Since it doesn't belong to A, my characteristic function value of A will be 0. Characteristic function on the subset B will be again 0. Substitute in the right hand side, minimum of 0 comma 0 will be 0. Now from 3 and 4 we have got psi characteristic function of A intersection B is equal to minimum of characteristic function of A comma characteristic function of B. Next subdivision, the statement is this: psi of A minus B is equal to psi A minus psi B, provided B is contained A. So now my B is a subset of A. Okay, just keep this in mind. So let me take x belongs to A minus B. Again by the characteristic function definition, since it belongs, psi A minus B value will be 1. Let me take it as equation number 1. Since x belongs to A minus B, x will be the element of A, but it is not the element of B. I hope you understand this. So normal set subtraction, if A minus B means what? X will belongs to A, but it does not belongs to B. So you rewrite this implies x belongs to A, replace minus by and. So x does not belongs to B. So since it belongs, psi A value will be 1. Since it doesn't belongs, x doesn't belongs, my psi B value will be 0. Again you substitute in the right hand side, it will be psi A minus psi B is equal to 1 minus 0, which is 1. So from first and second equation we have proved the result. So we have proved the result for belongingness. Now we'll move on to not belongingness case. So if x doesn't belong to A minus B, then by characteristic function definition, psi of A minus B will be what? 0. Again to just take this as equation 3, since x doesn't belong to A minus B, x is not in A as well as it is not in B. Okay, since it doesn't belong. So x not in A means characteristic function value will be 0, x not in B means again the characteristic value is 0. So psi A minus psi B will be 0 again. Now from third and fourth equation we got the result. Psi A minus B will be psi A minus psi B. We'll move on to the next one. So psi A dash is equal to 1 minus A. So tell me what is A dash? I hope you know A dash is nothing but S minus A. Universal set minus A is my A dash, and we call this A dash as a complement of my A. Okay. So if x belongs to A dash, again by definition psi A dash value will be 1. So take this as equation 1. Now to prove the right hand side, since x belongs to A dash, x doesn't belongs to A. So if it belongs to A, it doesn't belongs to A. if it belongs to A dash, then it doesn't belong to A. So psi A value, since it doesn't belong to A, my psi A value will be 0. So substitute in the right hand side, so 1 minus 0 will be 1. So from first and second equation we got the result. Again we have to prove for other case, not belongingness. If x doesn't belong to A dash, then by definition psi A dash value will be 0. Since it doesn't belong to A dash, obviously it belongs to where? A. So psi A value will be 1. You substitute in the right hand side, 1 minus 1 will be 0. From third and fourth equation we got the result. So then the next subdivision we have to prove characteristic function of the universal set is 1. Okay, so we already know S is a universal set, that is the universal. Okay, so the it will have only the belongingness, it won't have any other element apart from the universe. Therefore always the value will be what? 1. We don't have non-belongingness at all. Okay, so since S is a universal set, all the elements will contain in S, thus my psi S value will be 1. Now we have to prove the empty set is 0. Okay, so we know S is the universal set. Yes, so what is S dash then? S dash is nothing but S minus S itself. What is S minus S? Empty set. Okay, so my complement of S will be what? Complement of S will be what? Empty set. Okay, just keep this in mind. So here empty set and S are complement sets. Already we have proved if A and A dash are complement, then by the previous result we know psi A dash is equal to what? 1 minus psi A. So in the A dash and A you substitute the complement elements of phi and S. So psi of phi is equal to 1 minus psi S, and psi S is nothing but universal set and the value is 1, we have proved just before. So 1 minus 1 will be 0, that proves my results. So which is the end of the theorem. I hope you understand. If you have any doubt, you just post me in the classroom. So next we'll see 2 examples. The first example statement is this: if f of x is equal to x square and this x is valid in the whole real line, minus infinity plus infinity, and psi is a characteristic function which is defined on the interval closed interval 0, 9. I hope you remember I have explained you the closed interval part. Closed interval means you have to include the extreme values as well as the in between values. Now here I have to include 0, 1, 2, 3 up to 9. All the elements between 0 and 9 including 0, 9. Okay. Then on what subset psi composition f is a characteristic function? You have to find the subset in which my psi composition f is a characteristic function. So what is given? My psi is a characteristic function. Since psi is a characteristic function on 0, 9, by the definition of my characteristic function, psi of 0, 9 of x will be 1. When this x belongs to closed interval 0, 9. If it doesn't belongs to, what will happen? It will be 0. Okay. Now I want the subset for the composition of psi and f. We will find now. So psi composition f of Ax is equal to 1. X belongs to A and we have to find this A. Okay. Now since its composition, I can rewrite it as psi of f of x is equal to 1. What is f of x? From the question we know that it is what? X square. Substitute here. So psi of x square is equal to 1. We know psi is a characteristic function on which interval? 0 and 9, closed interval 0, 9. Therefore x square will belongs to where? 0 and 9. So x square belongs to closed interval 0, 9. We have to find x value. Okay. So to find x value, substitute the values here. When you substitute 0, what will you get? The square root of 0, which is 0 again. When I substitute 1, I will get plus 1 and minus 1. When I substitute 2, I will get plus 2 and plus root 2 and minus root 2. Similarly, if we substitute 4, we will get minus 2 plus 2 as values of x. and if I substitute 9, I'll get minus 3 and plus 3 for the as the value of x. And I cannot exceed 9 since my x square is defined only between 0 and 9. So I cannot exceed 9 as well as I cannot go less than 0 also. Okay, therefore my x interval will be, my x will belongs to minus 3 to 3, minus 3. It will take values from minus 3 to 3. It cannot go beyond 3 as well as less than minus 3. And this will be the subset for my characteristic function psi composition f. Okay, hope you understand. Next example is this. If f is a function from a to b and psi is a characteristic function of e contained in b, on what subset a is psi of composition f is a characteristic function. Since it's given psi is a characteristic function on E, which means by definition I can write psi E of x is equal to 1 when x belongs to E. So, and one more condition we have, this E is a subset of where? B. B is a codomain for my f. Okay, just keep this in mind. Now we are going to find the subset for the characteristic function psi E composition f. That means consider psi E composition f of x is equal to 1. Now by since its composition it can be rewritten as psi E of f of x is equal to 1. Okay, so since we already know psi is a characteristic function and with the subset E, therefore this x will belongs to where? E. Now